So this one does factor. Factoring doesn't do you any good in this case, though. Factor out an x, you get an x plus 2. What are you going to do with that? Well, I can't think of how that would work. No, I can't. I don't think that would actually benefit you. However, it's really easy to complete the square. Are there limits of integration? No. So it's really easy to complete the square, however. I need to add 1, so just add 1 and subtract 1. Right, all under the radical, of course. So this is integral square root x plus 1 quantity squared minus 1 dx. So x plus 1 is the secant theta. Then dx is secant theta tan theta d theta. I bet I don't try to say that that's a secant that comes out of that radical. I better get it right this time. So secant squared theta minus 1, theta minus 1, dx is secant theta tan theta d theta. So that's a tangent there, isn't it?
Yeah.
So that's integral secant theta tan squared theta d theta. Oh no, an odd power of the secant. Thanks a lot. You know what? I should be glad. I should be glad. You guys are asking me the hard ones. If you were asking me the real easy ones, we'd be in trouble. But you might notice, evidently they're all hard. Somebody want to tell me what to do here? Change what? Sines and cosine?
Yeah.
Well, let me look at it first. That could work, but I think probably we'll change tan squared into secant squared. And hopefully, well, 1 tan squared is secant squared minus 1. Yeah, this turns into, well, a horror if you don't have certain things memorized. Secant cubed theta. Do you remember what a nightmare that was? You had to use integration by parts and add the secant cube back over to the other side. So hopefully this is something you have memorized. Probably not. Anybody know what the integral for secant cubed is?
No.
It's in the table. Go ahead, look it up. First lesson today is how to use those tables. That's 7.6.
You missed the table over it on the exam, or?
Yeah.
Okay. So,
Not all of them, but the ones you need for things like this. So somebody want to just read it to me? What's the integral of the secant cube?
let's see.
1/2? No, wait, I think they have secant cube. You don't have to use the reduction. I think they have that one in there straight out, don't they?
Yeah, they do. I saw it yesterday.
Yeah, you don't have to use the reduction for it. It's in there as secant cube. Earlier in the same table.
It's at the end of the book.
Which number is it?
It's like 71 or something.
70. Oh, okay, or they did it in the examples. Yeah, they solved it. How about if we just write ...
Reference table.
What do you mean no? All right.
Is it 71?
71.
71?
Hold on. Is it? Yep, it is 71.
Nice.
All
Yep.
right, so read 71 to me.
70 minutes.
Alright, half of secant
1/2 secant
theta
tan theta
plus half
plus 1/2 ln
absolute values
of
secant theta
plus.
tan theta.
Now all that was the integral of secant cubed. Now we have to also put minus the integral of secant. So minus ln absolute value secant theta plus tan theta d theta. So now here's a simplification I would expect you to do. I mean, not a factor, combine those, they're the same thing, right?
So it's negative.
I mean, you know, I'm not going to expect you to change 3 over rad 2 into anything, but I would expect you to change 3 plus 2 into something. For God's sake, give me a 5. It's not a lot of work. So what does this become when I combine these two?
Negative 1/2.
So let's just change that to a minus and erase that, and we did it. Questions? What? I can't hear.
You need to substitute the X back in.
Oh, no. Oh, man. So I guess I am going to have to draw that little triangle, aren't I? So in this case, not doing that substitution is a bit more expensive, too. Ew. What a pain. So trig substitutions are notoriously ugly. And you can see why, huh? What do we have here? Secant theta is x plus 1. So draw the triangle. So it's easy to substitute for the secant. Right? We're just going to put an x plus 1. But the tangent is what's going to require some work, and that should bring us back to our original radical. So there's theta. Secant is the reciprocal of the cosine, so instead of 1 over x plus 1, it's x plus 1. No, it's the other way around. It is x plus 1 here and a 1 there. And square root x squared plus x?
2x.
2x. So now, every place you see a secant theta, you're going to write an x plus 1. Every place you see a tan theta, you're going to write a square root x squared plus 2x. So I guess you could factor out an x there, but it's not going to really improve things, is it?
Are you sure you're done now?
No. Are you? I got that on purpose. I just wanted to see if anybody was going to catch it. And if you believe that, I have this car I'd really like to sell you.
What is it?
It's under the bridge he has for sale.
Yeah, it's parked under the London Bridge.